There is no code requirement for an exterior light at an emergency exit door. The electrical contractor is mistaken. Building codes require emergency lighting and signage to illuminate paths of egress during a power outage or other emergency. However, this lighting is typically installed inside the building to guide occupants to the nearest safe exit. The church's decision to delete the exterior light is understandable from a security standpoint. An illuminated emergency exit door could attract potential intruders or provide a visual cue to people outside that the door is accessible. Churches and other facilities can enhance security around emergency exits by firstly installing an alarm system that triggers when the emergency exit door is opened, secondly placing security cameras near emergency exits, thirdly educating staff and occupants about the importance of keeping emergency exits locked and secure, and fourthly ensuring that the emergency exit door is clearly marked and accessible only to authorized personnel. Emergency lighting is a critical safety feature in buildings, designed to provide illumination when normal power is lost, ensuring occupants can safely evacuate. These systems are governed by various codes and standards, including the National Electrical Code, or NEC, and local building codes, which specify requirements for installation, maintenance, and testing. The primary purpose of emergency lighting is to provide sufficient illumination along the path of egress, including corridors, stairwells, and exit doors. This ensures that occupants can see where they are going and avoid obstacles during an emergency evacuation. Emergency lighting systems typically consist of battery-powered lights that automatically activate when the normal power supply fails. These lights must provide a minimum level of illumination for a specified duration, usually 90 minutes, as required by the NEC. The placement of emergency lights is crucial for effective egress. They should be located at strategic points along the exit path, such as at changes in direction, intersections, and near exit doors. The NEC provides guidelines for the spacing and placement of emergency lights to ensure adequate coverage. In addition to emergency lighting, exit signs are essential for guiding occupants to safety. Exit signs must be clearly visible and well illuminated, and they should comply with local building codes and the NEC. Some jurisdictions require internally illuminated exit signs, while others allow externally illuminated signs. The NEC also addresses the wiring and protection of emergency lighting circuits. These circuits must be separate from the normal lighting circuits and must be protected from overcurrent and short circuits. This ensures that the emergency lighting system will function properly even if the normal power supply is compromised. Regular testing and maintenance are essential for ensuring the reliability of emergency lighting systems. The NEC requires periodic testing of the system to verify that the lights are functioning properly and that the batteries are fully charged. Maintenance should include replacing batteries as needed and cleaning the lights to ensure optimal performance. There are several types of emergency lighting systems commonly used in buildings. These include central battery systems, which provide power to all emergency lights from a central battery bank, and unit equipment systems, which consist of individual battery-powered lights. Each type of system has its advantages and disadvantages, depending on the size and complexity of the building. The NEC also addresses the use of generators as a backup power source for emergency lighting systems. Generators can provide a more reliable source of power than batteries, especially for large buildings with extensive emergency lighting requirements. However, generators must be properly installed and maintained to ensure that they will function properly during an emergency. In addition to the NEC, local building codes may have additional requirements for emergency lighting systems. These requirements may vary depending on the type of building and its occupancy. It is important to consult with local authorities to ensure that the emergency lighting system complies with all applicable codes and standards. Emergency lighting systems play a critical role in ensuring the safety of building occupants during an emergency. By providing sufficient illumination along the path of egress, these systems help to prevent accidents and injuries and facilitate a safe and orderly evacuation. Regular testing and maintenance are essential for ensuring the reliability of emergency lighting systems and compliance with applicable codes and standards. Regarding security concerns, the decision to delete an exterior light at an emergency exit is understandable from a security standpoint. An illuminated emergency exit door could attract potential intruders or provide a visual cue to people outside that the door is accessible. Churches and other facilities can enhance security around emergency exits by firstly installing an alarm system that triggers when the emergency exit door is opened. This can deter unauthorized use of the exit and alert security personnel to potential breaches. The alarm system should be connected to a central monitoring station or security office for immediate response. Secondly, placing security cameras near emergency exits. Surveillance cameras can provide a visual record of who is using the emergency exit and can help to identify potential intruders. The cameras should be strategically positioned to capture clear images of the exit door and the surrounding area. Thirdly, educating staff and occupants about the importance of keeping emergency exits locked and secure. This can help to prevent unauthorized use of the exit and ensure that it is only used in emergencies. Staff and occupants should be trained to recognize potential security threats and to report any suspicious activity. Fourthly, ensuring that the emergency exit door is clearly marked and accessible only to authorized personnel. This can help to prevent unauthorized use of the exit and ensure that it is only used by those who need it. The exit door should be clearly labeled with signage indicating its purpose and should be equipped with a locking mechanism that prevents unauthorized access. Alternative security measures can include reinforcing the emergency exit door to prevent forced entry. This can involve installing a stronger door frame, a reinforced door, and a high-security locking mechanism. The door should be able to withstand attempts to break it down or force it open. Another measure is to install a door access control system to restrict access to the emergency exit. This can involve using keycards, biometric scanners, or other access control devices to ensure that only authorized personnel can open the door. The access control system should be integrated with the building's security system for centralized monitoring and control. Furthermore, consider implementing a security patrol to monitor emergency exits and the surrounding area. Security personnel can conduct regular patrols to check for signs of tampering or unauthorized activity. They can also respond to alarms triggered by the emergency exit door. Lastly, ensure that the emergency exit door is properly maintained and inspected regularly. This can help to identify potential security vulnerabilities and ensure that the door is functioning properly. The door should be inspected for signs of damage, wear, or tampering, and any necessary repairs should be made promptly. Emergency lighting is vital for safety. According to NEC Section 700.1, emergency lighting systems are essential for illuminating and ensuring proper operation of critical systems. Emergency systems are legally required and intended to automatically supply illumination and power to specific areas and equipment in the event of failure of the normal supply or when there is a disruption to the electrical system. Emergency systems typically include, but are not limited to, life safety systems. Section 700.12b discusses the capacity for battery-powered emergency lighting, which states that a battery must maintain voltage under a load for the class and division for a minimum of 1.5 hours. Section 700.16 discusses the external illumination of emergency exits, which states that where lights are on the exterior of a building and are used as emergency egress lighting, they must have the appropriate safeguards to ensure that the lighting is continuous unless intentionally shut off manually or controlled automatically. Section 700.26 discusses the coordination of the fire alarm system, which states that emergency lighting must be arranged to prevent its disconnection due to the unintentional or deliberate opening of overcurrent protection devices. Section 701.1 describes legally required standby systems. Legally required standby systems are those systems that are required and installed to supply power to selected loads, usually not related to life safety, when the normal power source fails. These systems are essential for maintaining critical operations in facilities such as hospitals, fire stations, and communication centers. Section 701.11 discusses the signals for legally required standby systems. It states that audible and visual signal devices must be installed to indicate conditions that could compromise the reliability of the standby system. These signals should alert personnel to potential problems such as low battery voltage or generator malfunction. Section 701.12 describes the capacity and rating for legally required standby systems. It states that the standby system must have adequate capacity and rating to supply all connected loads simultaneously. The system must be designed to handle the inrush current of motors and other equipment without voltage dips that could affect the performance of critical loads. Section 701.15 describes the transfer equipment for legally required standby systems. Transfer equipment automatically switches the load from the normal power source to the standby power source when a power outage occurs. Transfer equipment must be designed to minimize the interruption of power to critical loads. Section 701.27 describes the overcurrent protection for legally required standby systems. Overcurrent protection devices must be provided to protect the standby system from overloads and short circuits. These devices must be coordinated with the other overcurrent protection devices in the system to ensure selective tripping and minimize the extent of a fault. Section 702.1 describes optional standby systems. Optional standby systems are systems intended to supply power to selected loads either automatically or manually. Optional standby systems are installed at the option of the user and are not legally required for safety or emergency purposes. Section 702.5 describes the signals for optional standby systems. Signal devices must be installed to indicate conditions that could compromise the reliability of the optional standby system. These signals should alert personnel to potential problems such as low battery voltage or generator malfunction. Section 702.11 describes the capacity and rating for optional standby systems. The standby system must have adequate capacity and rating to supply all connected loads simultaneously. The system must be designed to handle the inrush current of motors and other equipment without voltage dips that could affect the performance of critical loads. Section 702.14 describes the transfer equipment for optional standby systems. Transfer equipment automatically switches the load from the normal power source to the standby power source when a power outage occurs. The transfer equipment must be designed to minimize the interruption of power to critical loads. Section 702.17 describes the overcurrent protection for optional standby systems. Overcurrent protection devices must be provided to protect the standby system from overloads and short circuits. These devices must be coordinated with the other overcurrent protection devices in the system to ensure selective tripping and minimize the extent of a fault. Emergency exits should be secure. Ensuring that emergency exits are secure while still meeting safety requirements is a crucial balance. Emergency exits are primarily designed for quick and safe evacuation during emergencies like fires or other hazardous situations. However, there can also be potential security vulnerabilities if not properly managed. Balancing security and safety involves implementing measures that prevent unauthorized access while ensuring the exits remain functional and accessible during emergencies. One of the key considerations is the type of locking mechanisms used. Traditional locks that require keys can be problematic because keys can be lost, stolen, or not readily available during an emergency. Instead, many modern buildings use delayed egress systems. Delayed egress systems allow the door to be opened after a 15-second delay, providing enough time to deter unauthorized use while still allowing egress in an emergency. These systems typically have an alarm that sounds when the door is opened, alerting security personnel. Another approach is to use access control systems such as keycard readers or biometric scanners. These systems ensure that only authorized personnel can open the emergency exit from the outside, preventing unauthorized entry. However, they must be configured to allow free egress from the inside at all times. Regular inspections and maintenance of emergency exits are also essential. Doors should be checked to ensure they are functioning properly, and any necessary repairs should be made promptly. The panic hardware should be easy to operate, and there should be no obstructions that could impede egress. Staff training is also critical. Employees should be trained in the proper use of emergency exits and the importance of keeping them secure. They should also be instructed on how to respond to alarms and other security incidents. In addition to physical security measures, it's important to have a comprehensive security plan that addresses emergency exits. This plan should outline procedures for securing the exits, responding to security incidents, and coordinating with local law enforcement. The plan should be regularly reviewed and updated to ensure it remains effective. Regular drills and simulations can help to identify potential weaknesses in the security plan and ensure that staff are prepared to respond to emergencies. These drills should include scenarios involving emergency exits and should test the effectiveness of the security measures in place. It's also important to consider the surrounding environment when securing emergency exits. Landscaping can be used to deter unauthorized access, and lighting can improve visibility and deter criminal activity. Security cameras can be installed to monitor emergency exits and provide video evidence in the event of a security incident. Working with security professionals can help to identify the most appropriate security measures for a particular building. Security professionals can conduct a risk assessment to identify potential vulnerabilities and recommend solutions to mitigate those risks. They can also provide guidance on complying with relevant codes and regulations.